Good morning. Okay, today is the 10th of October 2018. It's a Wednesday. This is the nybbles.io daily programming stream. My name is Jeff. I write code every day and I stream it here on Twitch. I am continuing to work on Basecode. Yesterday we made some pretty good progress with member access up to being able to handle pointers in line. In member accesses. And so this morning I kind of set out to try and enhance the code that I have to support that. So the first thing that I did was an AST evaluator for the binary operator evaluator function. Right, so we get an AST node in that's a binary operator. This converts it into a code model equivalent. So I added this case here. So if we have a member access binary operator and the left-hand side is an identifier reference, then we turn it into, and it's a pointer, right? So if the left-hand side is an identifier reference and it is a pointer, then we wrap that in a unary operator to dereference it. So that's fine, that works now. So what that allows me to do is this. Right? So now I can just have pointer dot pointer dot pointer dot whatever, and it will wrap those in the equivalent, this is what it ends up becoming under the covers, which is what we want. And then if we had, if we had our own struct, and it had a pointer to let's say this has a name and an age. So then a Bing, we have a pointer to a Bing, and then this, let's have bong, and a bong will have a temperature, right? So then you can have a foobar, and then a bang blunt temperature. Right. What this should do then is this would look like a bang blunt temperature. That's what that would become. And so this is, again, I don't know if I've mentioned this before, but this is why C and C++ have a different syntax for this. So when you have something like this in C, you can use the dot operator if you do this, right? But it's just, this is what the C or C++ compiler would make you do in this case to make that work. So instead, what C does, or C++, is it has another operator that behind the scenes, what that operator is doing is the dereferences. Right? It's the exact same code, really, in the end. It's just that the arrow operator, instead of having to manually write the dereference and wrap it in parentheses and all that good stuff, the arrow operator does that for you in C and C++. Now, why they decided that it should be a different operator, I don't know. But Basecode is just going to do that on the fly. You could just use the dot operator. I think the only, personally, I know some people really hate the arrow operator. I think the downside to doing it this way, where it's just implicit, is you are losing some context here, right? You have to remember that this is a pointer now. As where in C and C++, the compiler will just, this syntax is not valid, so it will fail, reminding you that, oh, hey, this is a pointer, this is not a non-pointer, so therefore you have to use this other operator to dereference it. So I don't know. I mean, I'm going to do it this way to start, and I'll see how bad it is, you know. And if it's particularly onerous, then maybe I will introduce some other way of accessing them. But for now, I'll leave it this way. But yeah, I could definitely see where it would, again, you'd have to just kind of remember, or you'd have to keep constantly referring back to the type declaration to know, hey, this is a pointer, and I'm navigating it in this fashion. So anyway, swapping that out for unary dereference, that works. So then the next issue is, and this is the code that I worked on yesterday, which works fine for non-pointers, but for pointers, well, it's actually not even just pointers, right? It's, I'm spaz today. It's really where any part of the member access path is not just an identifier reference, right? So this is really easy. When we just have identifier references, we don't really need to evaluate anything. We just look stuff up and it works. But let's say you had a, you know, current string putter, and that's a procedure, and it returns a string pointer, and this returns text pointer, just for the sake of demonstration, right? So this is current string putter. That should be valid, right? You should be able to do that. So it's not just it's not just unary, or I should say inline pointers. It's really anything, any expression. Now in this case, you know, this is returning a pointer. So what would happen is this would get wrapped, or should be wrapped, in a unary operator, because the result is a pointer. So what would happen here, or what should happen, is we get a unary operator, which is a dereference, and then the right-hand side of the unary operator is the function call, right? But that didn't work. Right, because see, I was too simplistic in my thinking here, which is not right. See, I had limited this, you know, to just identifier reference, and that's not really correct. And I think what I'm going to end up having to do is make a helper function here because there's actually a universe of things that are valid here, but not everything. So I gotta figure out, yeah, that simplistic condition wasn't really correct. Oops. So we should hit this now, which we do. Okay. So the left-hand side currently is a procedure call, which is exactly what I expected. It's a procedure call that returns a pointer. So therefore, we have to dereference it in the path. So this wraps that up. And then if we look at the code output, so here's where we set the pointer from the address of. Here's the call to current string putter. We pop that address off, we dereference it. So yeah, actually that's all correct. Now, current string putter, I'm not actually emitting procedures right now, so this is not doing anything. But yeah, in general, right? If I were emitting procedures properly, this would be correct, right? So, so this is the idea, right? It doesn't just have to be a pointer. And then in this case, we're dereferencing the pointer inside the procedure, returning a copy on the stack, which should actually just be an address, but and yeah, so then we don't have the pointer dereference anymore because it's not returning a pointer anymore. So, you know, so obviously this should be valid. Being able to just refer to the pointer directly is valid. Now, what isn't valid? Oh, obviously a manual dereference should be valid. See, and this is where we'll get in trouble. We're going to fall in here. Well, no, is that right? No, actually we won't, because the dereference will return a type of, because what that is, that's a unary operator that has the field, the identifier reference in it. And when you infer the type of the dereference, you get the underlying type, not yet. So we didn't hit this. Yeah, so you get the underlying type, which is the string. Oh, no. No, that's right, because I put it in there manually. Duh. Never mind. So yeah, that works. So we can do it either way, right? And it works. Now, oh, also, I know I wanted to test this. This should be fine now. Because now it'll evaluate, it will recursively evaluate the expression group and go into the unary operator. Yesterday that was causing a problem because I didn't have the code that would evaluate that part of the expression. Yeah, so it ends up, you know, the parentheses are meaningless really, but they get evaluated and stripped. So, and also this should also be valid. Yep, perfect. Okay, so that's all goodness, you know. But, always a but. Well, before I go there, I think the other things that probably should, you know, I don't know. I'm going back and forth on whether or not I want to allow pointer arithmetic. But I mean, right now, you can do it. Right, so yeah, but in this case, it doesn't really make much sense. Okay, I'll worry about handling all the edge cases later. Edge cases are fun. Okay, so here's the next issue. The next issue is, okay, so this corresponds to line 9 and 10. So we get the address of the text pointer variable. So remember, a pointer variable is an 8-byte block in memory that holds another number, which is what it's pointing to, right? So, and whether that's on the heap or on the stack, doesn't matter. You know, it's the same thing. It's 8 bytes. On a 64-bit platform, it's 8 bytes. And it's always 8 bytes. So we get the address of the variable for the pointer. We get the address of text, right? Which is another structure living in memory. That's 16 bytes living in memory somewhere that has hello world in it, and length and capacity, right? It's a structure. And then we store that address in the pointer. So again, I don't know, maybe it seems obvious, I don't know, but just for clarity, you know, this is when you get to the higher level representation of this stuff, it can be a little bit confusing because you think, oh, this is a pointer to a string, but really that underlying type, all that's there for is the compiler to assert that what type you're actually pointing at. So like, again, when we do this sort of stuff, right, it works the same as this, but also if you support pointer arithmetic, you know, adding 1 to text pointer isn't adding 1 byte, it's adding 16 bytes. It's adding the size of string to it because it's a string pointer. So if you add 1 to text pointer, you're moving the size of a string in memory, if that makes sense, right? So if you had a big chunk of strings, and the structures are all the same size, which they are, then theoretically you can walk through those by just adding 1 each time to text pointer, and that moves you 16 bytes, 16 bytes, 16 bytes. Okay, so, but at the end of the day, the pointer is just a quad word. It's not anything else, not anything different than that. So we get the address of the pointer variable, we get the address of the text structure that's in memory, we store that address in that variable, right? So then we're going to make this procedure call, and so this has to be evaluated, right? So we get the address of the text pointer variable. So, but what is the text pointer? So when we load it, we load that quad word into I3, and remember every register is 64 bits in the interpreter. So we're loading 64 bits from this address into this register, the value into that register. So I3 now holds whatever address this pointer points at, which happens to be 268 hex. But that's meaningless, right? On its own, the pointer value it's just the pointer value, it's just the address. So this is where dereferencing comes in. We need to load that pointer. We need to load from that pointer to get at whatever's at that location, I guess, is one way of looking at it. But this is interesting because in this case, hey, Dark Knight Studio. I'm good. How are you? Yeah, so see, in this case, do we actually need the dereference? What happened to your foot? Hmm. I'm working on Basecode. Right now, I'm specifically working on getting member access to work, which in a simple case it does. Hey, Lori Master. I'm right now kind of working on the pointer scenario, which is interesting because I think I just realized it's kind of interesting. The way that the variable stuff works. Hey, move. Yeah, so what's happening? That's interesting. That is interesting. So Lori Master says, I've been reading the HTTP protocol RFC and I'm starting to question why they chose text-based protocol at the time rather than just binary. Also, do you know of any other standardized and widely used web communication protocols? So, my text. Hey, CM Griffin. Good night. I saw the notification. Okay. Context switch. So, why text? Well, I mean, if you go back in time, right, and I forget exactly what year that RFC was written. Let's see. So 1.1 was 99. So let's see, this was, oh wow. Yeah, okay, so this was even earlier than I thought. So, okay, I think this definitely probably has a lot to do with the answer. So this is older than you think, right? So that's number one. And a lot of the, again, not the web, but because to me the web is Berners-Lee, HTML browsers, the internet, and the founding protocols of the internet, things like HTTP, FTP, Gopher, Telnet, DNS, all that stuff, right? Those are much older than you think, right? Like old. And back in that time, you have to remember that Teletype, meaning a typewriter hooked up to essentially something not much more complex than, the old-fashioned, what were they called? Where they would tap out Morse code, telegram system. Not too much more complicated than that. And in many ways kind of formed from that premise. So you have to take into account like ASCII, and probably to some extent in parallel with that EBCDIC. These things represented teletypes. They represented a keyboard that had text, and that was it, and a couple of special punctuation symbols. We're not even talking about extended ASCII yet. We're just talking about 127, 7-bit ASCII is what we're talking about here. So it's not surprising to me that back then, because everything was kind of teletype, and it was, here's a stream of text characters, and we're going to process those stream of text characters, and we're going to pass it somewhere else, that they built most of those protocols around text. Like Telnet is text, Gopher, text, FTP, text, HTTP, text. And again, not extended ASCII, not modern Unicode, 7-bit, A through Z, 0 through 9, some punctuation, boop, that's it. Hence the need for things like escapes and all this other stuff, because it was a pretty limited source set of symbols to work with. So, yeah, you have IRC. Again, there's tons of founding protocols. The finger, all that stuff, right? So, and I think there was because a lot of that stuff came from DARPA, came from the government, I think in kind of maybe an amazing example of the government not screwing something up, sort of, they had this future-looking perspective on a lot of these internet protocols that were, hey, this needs to be universally interoperable, right? This would have been the mentality, right, of someone, I would assume a group that was trying to build a networking environment that would sustain a nuclear holocaust. So, yes, there's a penalty for doing it that way, but I think at the time, again, we're not talking about people who are worrying about building web applications that scale to gajillions and gajillions of users. They weren't thinking of the internet that way. They were thinking of the internet in its original intended design, which was not centralized, peer-to-peer, oh, this university is going to put up computers, that university is going to put up computers, that government office is going to put up computers, and we're going to have this huge, big, you know, peer-to-peer network, and it's going to be really robust. It's going to, you know, SMTP, forgot SMTP, POP, you know, email, right? All that stuff was text, and it was interoperability, ease of implementation, ease of understanding, ease of troubleshooting, right? And I think also, yeah, again, I think that was why, for the time, I think they chose 7-bit ASCII, right, for all that stuff. Now, fast forward to today. Does 7-bit ASCII make sense for the stuff that we're doing now? Probably not. And could they have done something in binary? Sure, they probably could have. The other thing, and this is going to sound really weird, but it's true. So I encourage you to look it up. So we have to go way back in the past here, prior to the 1970s. Bitness, what we consider to be binary today. Now, binary's always been 1 and 0, but the way in which binary is interpreted by different machines' architecture was wildly different and much more diverse back in that era than it is today. Today, we've kind of settled on this: a byte is 8 bits, you know, 2 bytes make a 16-bit word, you know, da 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 da. There's tons of history that has kind of sifted that down to what we consider to be, that's the way it is, and it's always been that way. But the reality is it wasn't, right? You know, PDP, some PDP systems, I know some IBM systems, there were lots and lots of systems that did not assume 8-bit bytes. You know, some had 10-bit bytes, some had 12-bit bytes. So I can definitely see back in that era a bunch of engineers getting together and saying, well, I could almost see the arguments, like what a binary thing is the way to go, but then a bunch of guys be like, yeah, but how are you going to support that Burroughs machine that's, you know, got a 13-bit byte, you know, that doesn't work. And so I think all those things, right, the fact that the lineage from this stuff comes from, you know, Telegram, Teletype, and that was closer in history than you think. And the reality of hardware at that time, and what they thought would be the reality going forward, I think it just pushed them in the direction of preferring 7-bit ASCII, right? And yeah, but again, that's its history. Where we are today is very different. So is binary better? Yes. And in many ways, because we have standardized so many aspects of the hardware side of this now, the interoperability issues that probably would have been present in the 60s, 70s, and 80s, probably even the early 80s to some extent, those are gone, right? Those are things of the past. I'm not saying there aren't systems that are a little different here and there, but they're probably extremely rarely used. And let's face it, you can probably write some software that manages to convert and manage that for you nowadays. So I think, yeah, binary makes a lot more sense, certainly more efficient, Oops, I forgot to plug my light in. Hold on one sec. There it goes. Okay. Battery doesn't last very long. What was I saying? So then you asked for, are there other web protocols, which again, like the web is one. That's not my computer, that's my fan that's blowing on me. So I have two fans running in the room. So that's what you hear in the background. So obviously there are things like GRPC, which really GRPC is just a wrapper around protobuf. So I would say even lower than that. You have things like protobuf, Captain Proto. I'm sure there's other examples of that. Those are the two that I've used the most. I prefer Captain Proto to protobuf. It was written by the same guy. He just wrote Captain Proto after he left Google. And so those are an option. As far as, do you wrap stuff in HTTP? Again, it comes down to pragmatism, right? The infrastructure of the internet now is a bunch of servers that understand HTTP and can cache things and deal with security and all this other stuff around that. So if you want to kind of sort of fit into the groove of what's out there, then that would be the way to go. Right now, again, you can put a binary payload in HTTP, and of course, Spider, HTTP2, whatever it's being called these days, is obviously going to be much better at doing that than the older text-based protocols, but the text-based protocols work just fine too. So yeah, you have a ton of options in terms of you can do whatever you want protocol-wise. And then the question is just, do you wrap it, do you tunnel it right through HTTP, or do you do something else? And obviously doing it, doing something different, right, is going to be more difficult from a network topology standpoint. Just opening sockets and, trying to communicate outside of the standards now. Again, there's no reason technically why you couldn't, but you're going to have issues if people won't open their firewalls or, so on and so forth. But then theoretically too, you could run everything over VPNs and then it really wouldn't matter. So, yeah. So as usual, with all engineering stuff, it comes down to what are you trying to do? What trade-offs make the most sense for that? And what's the cost-benefit analysis for those? But yeah. I thought thrift was a Facebook thing. Maybe I'm misremembering it. Maybe they made it an Apache project. I don't know. But I kind of vaguely remember I thought that was Facebook's version of protobuf. If I remember correctly, the thing I didn't really care for with Thrift, and quite frankly, I don't really care for GRPC, is they try to do too much, in my opinion. Like, they create service stubs and, all this stuff. And it's, sometimes that can be helpful if you're just doing really quick prototypes. But then you also fall into the trap of, if there's an issue with their generated code, you're kind of screwed. That's why I think I like Captain Proto, because it'll just kind of let you do this. In Protobuf too, if you just use Protobuf directly, you can just use them as serialization mechanisms. But yes, sir. I'm a big fan of 0MQ, and many systems that I've built over the years have used that. And I've built, WebSocket proxies for 0MQ, so that sort of stuff can cross over a web boundary. But yeah, in general, like communications, any kind of IPC, essentially, I think one of the big issues is you can build a lot of good stuff on just RPC, but there are limits to that. And RPC, if it's RPC everywhere, then you have to build plumbing on the endpoints to deal with RPC failures, especially when you start getting into the distributed context. I mean, obviously making procedure calls locally in a process, or even in process on the same machine, your chances of having issues are fairly low, although not zero. But as soon as you start crossing over the network and you have latency and a whole slew of other issues, right, which time delayed or phase changed transactions, however you want to look at it, you need a more complex model than just remote procedure calls, which, let's face it, is what most web applications are, right? Even REST, it's just another way of doing RPC. So I remember reading things online about some people who disliked 0MQ. I know about Nanomessage. The last time I looked at Nanomessage, it was way, way behind where 0MQ was, and it had a lot of catching up to do. Now it's been maybe a year or so since the last time I've looked at Nanomessage. So honestly though, my recollection, and in all truthfulness, I tend to ignore this shit. I don't really pay attention to it when it becomes personal and political. I'm almost positive the guy that started Nanomessage used to work on 0MQ, and they just had a difference of opinion, right? I forget the guy's name, Martin, I think he passed away last year, but from cancer. But the guy who was really spearheading 0MQ, I think he had a particular vision of what 0MQ should be conceptually and how it should work. And I think some of the guys who were actually building it had they had pragmatic concerns around certain things they were trying to do. And so, I'm going from memory here, and my memory sucks, but that's my recollection of the whole 0MQ Nanomessage thing. And kind of piggybacking on that, the Nanomessage project sort of, I think, started to attack 0MQ and say, oh, look, this is flawed, that's flawed. And again, a lot of that stuff depends on your perspective, right? It depends on what you're doing. It depends on how you approach it. Now, the one thing I will say about 0MQ that I think was part of the issue the Nanomessage guys had is that 0MQ was really not, it wasn't intended to solely be software, right? They had implementations, but those were supposed to be references of the actual RFCs. So really the 0MQ project kind of was evolving to just a bunch of RFCs. Here's what all these different things are. Here's how they work. We've proven these in these environments, this size, this many messages, this kind of failover scenario. Here's a reference implementation that we built, but it's just that, right? It's just a reference implementation. It's not, and we might create another one. And I think that's one of the issues with 0MQ is there are a couple different versions of 0MQ that are out there in the official repository, and it can be a little confusing, right? But if you kind of understand what the history of the project was, you can sort of weed through that a little bit. But I've used the C and C++ code base that's available for 0MQ for years, and I've never really had any major issues with it. So that's not to say there aren't bugs, and there's not to say there aren't, every piece of software has threading issues. But I've always had success with it. So, and I haven't looked at Nanomessage in a while, so I probably should take a peek at it again and see if it's gotten any better from what it was at the time. Oh, now I lost where I was at. Okay, so what I'm doing here is, like I said earlier, I'm working on refining this code to support pointers in the member access path. Yeah, so that looks correct. So yeah, I think part of the problem, what was confusing me, was that unary operator is actually the pointer dereference unary operator was actually implemented slightly incorrect. So what do I mean there? What I mean is, so if I have a char and it's a rune, do I want to do it that way? Let's just do it this way. So do that. So then if I have a char pointer, and I dereference that, this is a value. It's not a composite. So when I dereference that, I actually have to load what's at that pointer. I have to load the value because it's a value type. It's a primitive. It's probably a better way to say it. It's an integer. It's a Boolean. It's, you know, a float. It's a scalar value. So in that scenario, the way I had implemented the pointer dereference, yeah, so there's the letter A, right? So here, let me put a new line here, kind of separate these. So in that case, the pointer dereference, like I say, has to do that extra load because we're actually loading the value of that scalar value, that scalar type. So here's where we set char pointer to the address of char. And then here is where we do a pointer dereference where we actually have to load the value, the byte that pointer is. When we dereference it, that's what we're expecting to get. We're expecting to get the byte or the short or the whatever, 16-bit value, 32-bit value, float value. We're expecting to get that as part of the dereference. However, so then when you talk about, and I'm just going to say composite type, right? The other languages would say object. I want to try to avoid that word, but this is a composite type, meaning that if you were to think of what is the composite type, it's the address of wherever it starts. That's the beginning of the type in memory. And then there are fields within that type that may be primitive values, but they may not be. So the issue with the dereferencing operator was that it was always doing this here, where it was loading the primitive value. But in the case of the structure, that's not really what we want. All we want is to address it. We just want to load the pointer value because that's what it is at that point, right? So we want to get whatever the value is in the pointer variable, and then other stuff can happen from that later. So that actually fixed this, and then that looks much more correct. And I think what I should put here is load primitive value from pointer, right? Because that's what that specific case is doing. Okay, so then we back here. I think this is correct. So this is the loop that takes the member access binary operator. If we haven't started down the path yet, we have a special case where we evaluate the left-hand side of the first binary operator into a temp if it's not an identifier reference. In other words, if we've got another binary operator or unary operator or whatever, some other complex expression that is the left-hand side, then that means we need to put a variable, we need to activate that variable, and we need to read it, because that's going to cause that to emit, and then we get whatever behavior for that particular expression we should get. So these flags are set. So the left-hand side or right-hand side is set to true for read if the element type of that is not just a simple identifier reference. Most, probably like, let's say 85% of the time, member accesses are going to be, identifier. So usually we don't actually have to activate them. We don't have to read them. Because in that scenario, the way the variable class works, we address the root and then we get an offset and we're done. That still holds true. But now if we have more complex things in the in-between that need to be evaluated out, then those will be evaluated here. And then on the right-hand side, so in the special case here where we're starting from scratch, right, we evaluate the first left-hand side, then the right, get the field from that for the right-hand side. That flows down here. Same thing with here, where we had a previous read. Now we're getting the next field from that off the right-hand side. So if the right-hand side's also, so you could imagine you could have foo.bar, where foo is a pointer and bar is a pointer. So in both of those cases, you have a unary dereference there. They both need to be read. So we would read this, and then we would read this down here. And that'll just repeat until we get to the end, and we end up with what we had before. So then, so let's do something silly. Let's say char pointer, because this should generate an error, because those fields do not belong to char pointer. A byte doesn't, it's not a composite type, so that's should be an error. So let's make sure that still works. I know it works with a non-pointer field, identifier reference. Yeah, so there's, So let's do this. So actually, this should be bombing here, right? Because we should be falling into, yeah, we should be falling into here. So let's take a look. Because the left-hand side in this case is not, it's not a composite type. Well, it is though. Yeah, I think I just realized where my bug is. Identifier reference. Oh. Okay, so it is creating the error. Why aren't we getting... Oh, I see the issue. See, this is one of those interesting cases where actually though, now that I think about that, that should not, this should never be null. Actually, take that back. Is wrong. Because even if it was an empty, we would still get a valued argument list back. It would just be an empty list. So if this is null, then we need a bail on that. Cool. I'm fixing more bugs. Yay. Okay. Yay. Okay, good. So that works. So we can't just, after I fix my plumbing, we can't just arbitrarily throw anything in there and expect it to work. So now let's try the other side of that coin. Let's put xputter back. And let's do len and cap, right, which don't exist. Yep, cap's unresolved, len is unresolved. Perfect. Okay, so those are gonna work, I think. Now, we're gonna do something interesting though, or try, we'll see if it works. Okay, 11, 32, perfect. Now, let's dater. So what we're going to do, data is a pointer. So what should happen here, the data is a pointer to a U8, right? So this is a byte array. So what should happen here is exactly what I did up here. We should get a dereference here that shows the first character of that byte array, which would be an H, lowercase h. And we didn't. So let's see what code we got here. Okay, so we load up the text pointer, we get the address, we get the capacity, we load up the text pointer address, we get the value of the pointer, we load, yeah, see that's what's not right here. Why? But see, that's weird. Why is it not? Well, wait. Okay. This is. Oh, yeah. No, I know what the problem is. Okay, so. Hey, Slayer Darth. Hey, Magnum Baguette. Oh, kaboom. I blew it up. The coffee will help. Yep, I am writing a compiler. The language I'm writing the Bootstrap compiler in is C++, so this is C++. The language that I'm creating is called Basecode. I have not heard the news. What happened? Yeah, I know who he is. I met Ben years ago. Years and years. Oh, that's a shame. I was afraid you were going to tell me that. Hopefully Rob Hubbard doesn't pass away anytime soon. Yeah, believe me, I am feeling I'm feeling my age lately. This is one of those things that nobody really tells you when you're young. Some people, I think, just because of the nature of their families or whatever, are maybe exposed to more deaths early in their life. But in general, I think most folks nowadays, it gets deferred. But yeah, after you're past 40, you start hearing about all the people who are passing away. And that seems to be kind of more common pattern. Okay, so what I need to do, because what I did up here is I'm wrapping the left-hand side of the member access. If it's a pointer, it needs to be dereferenced. I wasn't wrapping the right-hand side, so that was a flaw. So I fixed that. So this should now be wrapped. The left-hand side and the right-hand side should both get wrapped into dereferences. Okay, so the left-hand side is the unary operator of type pointer dereference. And now we're going to wrap, so the right-hand side is an identifier reference that is a pointer. So we're going to wrap that. So now the left-hand side and the right-hand side are those identifier references wrapped in pointer dereferences auto-magically by the compiler. Now, of course, it's blowing up in other places here. Hey, Robbie. I am working on my compiler for Basecode. Okay, I think I know what's going on here. Yeah, we're assuming it's a var, and it's not. This is code for a compiler that I am writing, Bootstrap compiler for my programming language, Basecode. Yeah, except I won't be here very long. I had to go on the road again. Yep. Okay, so I had to change field here, the field method on variable a little bit, because we want to look up the field by name. So we need to have code here that's going to assert, right, that we can actually extract an identifier from whatever comes in here. So that's good, but then the other issue was, in this case, I don't want the identifier that we find to be the element that goes into the variable. I want the unary operator to be. I want the original element that came in. In the case of, well, and in the case of the identifier reference, it's fine, right? So yeah, we want to pass that original element through in that case. So that's what gets wrapped in the variable, because we still want to evaluate that expression, whatever it is. We don't want to skip over that. And variable needs to have that, right? So if it's just the identifier, it's not going to do the right thing in that case. But if we call field, we don't pass an element, it's null, then we just use the identifier like we were previously. So in cases where we were calling this without having a specific element, we're just looking it up by name, that will continue to work. And then in this case, this will also work. We can pop the identifier out of the pointer dereference and use that to look it up. And we also pass the unary operator in. So then what should happen is then this gets dereferenced, that gets dereferenced. So, but it should be both types, right? So text pointer gets dereferenced. We just get the address. Data gets dereferenced because it's a primitive type. It will actually load the value at that pointer location as part of the dereference, which is what we would expect. I'm going to take a really short break, make some more coffee. I will be right back. Okay, I returned. What do we get here? Well, first, let's look. Did we? Yay, it works. All right, good. So, let's look what we got. Yeah, so here's where we get the length. Here's where we get the capacity. And then we get the data field, but it's a primitive. So when we dereference that, we expect to get the value that that primitive pointer points at, which happens to be a byte. So we load the byte, and that's what gets pushed on the stack, and that's what gets printed. All right, so I would say that's fixed. So then we can do this. And now what's interesting is this prints the address of data, right? This dereferences. So So then the question is, which behavior do we want? Okay, so this is accessing the text string as through a non-pointer, right? So this is accessing the global variable directly. Now, pointer, non-pointer. Like, in the end, the code that gets generated for a lot of this stuff, it's always pointer-based. Now, some of that has to do with the fact that the interpreter is a load store model, but even then, I mean, even if it weren't specifically load store, we would still be treating these as addressed things, right? But here's one difference right here. In this model, data is not dereferenced automatically. So oh no, I take that back. It is being dereferenced now. Well, right, because I changed it. So actually, okay, so let me rerun this. I didn't think about that. It's going to impact both. So actually, that's consistent. So then do I like it that way? I don't know. Maybe. Yeah, it's consistent now. Okay, I can live with that. Okay, so here's the issue. Okay, so here's problem number one. What if, in this context, I didn't want to dereference this? I wanted the address. I wanted to treat it like the pointer that it is. So we could make a rule, right? We could say that if the underlying type of the pointer is composite, meaning it has fields, we will automatically dereference it for you because the notion would be that you want to navigate. But if it's a primitive type, we will not automatically dereference it. So in the case of data here, data would just be treated as a pointer in that case here because it points at a U8. It points at a primitive type, not a composite type. I think I like, hey, Tech Johnson. Ooh. Hope it's not too bad. Yeah. Oh, that's not good. Okay, so if we wanted to make that change, that's in the evaluator, right? Because it all comes down to when we're gonna wrap it. Now in this case, yeah. So I think what I'm missing here is so what I gotta do is I gotta pull out the pointer type here. Well, I hope you're able to find something. Hey, Tech Johnson, what area are you in? Are you in the US by chance? Pennsylvania, huh? Yeah, I had somebody reach out to me saying they were looking for a bunch of people in the San Jose, California area, but I don't know if any of these support remote. Hey, Tech Johnson, if you shoot me an email, I'll forward this to you. I don't know if they would entertain remote. They might. A couple of these, they're looking for, Web UI, React JS, Web UX. So, might be a fit. Slayer Darth, you have to put me on the big screen TV at work and, have me get on a rant. Everybody in London would think I'm an absolute git. Awesome. Okay. So what I did here was, it's not enough on the right hand side to just say is it a pointer. We also have to look at the base type of the pointer, say, hey, is that a composite type? Yeah, okay, then we're going to wrap it. Otherwise, we're just going to leave it as is. So then what that means is this is going to become a just a pointer again. So and then we can, if we want to dereference that primitive type, then we can. I like that model. I think that works. Tis logical. All right, let's see if I got it right. If I did, then I'm going to say that's pretty darn good. And then we'll review that and make some notes about what comes next. Uh-oh. Oh no. Mr. Bill. Mr. Bill? You guys have never heard, you've never heard of Mr. Bill? Gumby. Oh no, Mr. Bill. I used to watch these. Oh, man. And they're really quiet. Good old Mr. Bill. So I bet it's these that are the problem. I think I know why. Yeah. Okay, I think I know why. Yeah, you can email him directly if you want. Of course, you can check out their website too. Yeah, you can tell him I referred you. Oh, crap. I did it backwards. Yeah, that makes sense. Okay, that's weird. That worked. What the hell? What the hell? Okay. That's all good. 1132 address, a 1132 address. Okay. I'm confused. I don't know if I changed anything or not. Yeah, it looks fine. Okay, that's the one that's busted. Interesting. Okay. I wonder if I'm accidentally wrapping it twice in that case, which would be bad. Dereference, dereference. No, okay, that's good. So here's our dereference right here. This, though, is this is just the base. This is the first one. So I'm going to skip over that one. Okay, so now both of them require a read. Okay. Oh, wait though. What's element? Unary operator. Hey, okay, because yeah. I'm going to switch the order of things a little bit. We'll always disassemble it, and then we'll run it, because I can't see what code it's generating. Okay. Yeah, okay, so what do we got here? So we get the text pointer and we load the pointer into, ooh, yeah, registers are off. Okay, that explains it. So something is, okay, so we're only going to read the right-hand side if it's not the last one. If it's the last one, we're not going to read it. We're going to let the caller read it, because that's what's happening there. Is we're marking the last one as skip deactivate, and yeah, registers are not being properly deallocated, I think. Oops. And that's okay, because in all these cases, there's somebody calling variable and then doing a read, except the register's not, or the value's not right. Okay, so we load, oh yeah, see? It's still not using the right. Say what? Why is it doing that? Yeah, this is not, we're reading from length, essentially. That's not right. Well, no, wait. I felt confused. No, this is right. This is not. That's the issue. And the reason for that is text pointer, load it. Yeah, but then this is off. Why is that off? Okay, so I've kind of restructured this a little bit because first, we only are falling into this block of code here if, and only if, it's a member access binary operator to begin with. So we know we're guaranteed to have 1, which is the one that came in. And the left-hand side is, it was a special case anyway, right? The very first entry into the vars array. So having that in a loop really was redundant. It doesn't need to be in there. So we can grab the first, handle the left-hand side, and instead of having the temp var, which I think was part of the problem, because I think it was falling out of scope and it was deactivating and it was causing problems, now we'll have a persistent chain from the root all the way to the very final leaf node. So we do the left-hand side, then we loop. We have to reprocess the same entry because we're always doing the right-hand side at that point. So we grab the top, we pop it off. Then we do the rest, right? We grab the previous, which in this case is going to be the left-hand side, and so we grab whatever the previous was, which in this case, if it's the first, is going to be the left-hand side of the very first binary operator. We make room for a new one. Should we read the right-hand side? We read from the previous variable for the right-hand side field, put it in the current one we just added to the list, activate it if necessary, and then read it if necessary. And we loop until we're done. And then at this point, it's always the previous variable handle getting the field based on the right hand side, because if you have x dot y dot z dot whatever, it's, you know, the first one, and there's another member access nested, you know, all the way down on the right hand side. So this change, I think, will accomplish 2 goals. One, it eliminates that temp variable that I think was causing a problem in the loop. 2, it moves one part of the loop out it always happens at the beginning, and it just doesn't make sense to have it in the loop, and so then the loop is simpler. So let's see if my my reasoning holds. You never know. Yep, look at that. I fixed it. Woohoo! Yeah, so I think what was happening is that temp variable handle, it was getting reclaimed, right, in the loop, and it just, in that particular case, it was actually impacting the register allocation. Oops, need to do that. This is what I want. Okay. So output looks correct in both scenarios. Ooh, well, maybe that doesn't look correct. Well, so let's look what we got here. So this is the one where we're dereferencing data from text pointer. So we get the text pointer variable, we load the address that's in the pointer, then we're going to load the data field from that, right? So I3 has the address of the beginning of the text variable, which is a string. We're going to load the data field from it, which is 8 bytes from the beginning. That So we're using I3 as the source address, I2 is the destination value, and 8 is the offset from I3. So that's loading the pointer value of data into I2. So then from I2, we're loading the byte, pushing the byte. That's correct. That's okay. So now, the one just above it is not correct. Right, now see, this is off. Why? Why? This is loading from I0, not I2. This is wrong too. This is loading from I1, not from I3. Okay, so I just succeeded in moving it. Oh yeah, I just noticed now that's wrong. Okay, so what the fudge crackers? Make it a little smaller. See if I can narrow it down. Yeah, it's still broken. Okay. Okay, so it's not that. So I think I know, because I'm going to make a guess that this is fine. Maybe I'm wrong, but I think this will be fine. And the reason for it is because we're not going through an extra step like we are with the unary operator. Yeah. Okay, so I think the issue is right here. It's this. Because if we go to unary operator and we look, the addressing part is not considering the, so yeah, you know what we gotta do. Which, we're going to move target reg with RHS var value reg. I think that's the issue. Because that's another variable, right? Inside of the unary operator, we're going to the session and saying, hey, for this element, this unary operator, give me another variable. That's another set of registers to allocate. And the target register is coming from the other variable, but it's, yeah, there you go. Now it works. It wasn't being tied together. So that was what I missed. In the case where we're skipping over loading the primitive value, I have to, you know, wire the addressing of the unary operator back into the target from where it came from whence it came. See, because this is the thing that caused this to happen. And so this guy is using I0, I1. I1 was the target register that it told the unary operator about, not that part. But he's allocating his own stuff, right? So we just have to swap those registers in. Okay. So I added this thing called copy, which I'm not using, and it was not correct. So I'm just going to get rid of it. Okay, let's put all this back in. Run the whole thing. And it should be wunderbar. Okay. Okay. 1132.878H, 1132.878H. Let's go up to, oh, well, that's a heap location for the string itself. Right, so that's fine. Yeah. Totally awesome. Pointers, yeah. All right, sweet. So we can now do member accesses with things that are auto variables, I guess, the equivalent. This is a global, but if it were a stack thing, it would be the same, right? So not accessing it through pointer. If the pointer points to a composite type, so in this case we have text pointer, which is a pointer to a string. So that's a complex type, it has fields. The compiler will automatically translate these to dereferences, so you can navigate through pointers without having to worry about that. And we're not using alternate syntax for the member accessor in that case. For pointers that point at primitive types, so integers, floats, bools, runes, those do not automatically dereference. If you wish to dereference them, you can do it manually. Otherwise, you get them as just pointers, which I think it makes sense, right? If it's something that you can navigate through, the compiler will help you do that if you want. Otherwise, you're on your own. You decide how you want to treat that pointer data. Wow, super awesome. So let us review. So we've been looking at the test file. So it's grown a little bit. We print out data in two ways, right? We print the address of it, of that pointer, treating it as a non-dereference thing, and then just as a test, we go ahead and dereference it as well, just to prove that, hey, that does in fact return the first character of that array, right? That buffer in memory. I create a single byte here with the ASCII value for A. I create a pointer, and then I get the address of that and print it just to prove that dereferencing that single character works, and that does indeed work. And then we create a string pointer and get the address of text. And so this pointer points at that. And then we can do the exact same thing we did above using the pointer to navigate to those things, and it does the exact same thing. The end result is the same. So in ASCII evaluator, I had a couple of bugs where I wasn't checking for things and bailing. So if we try to get an ARG and that fails for whatever reason, we need to bail here. I just hoisted up Builder here because I'm using it in a couple spots now. So then I had done this slightly before the stream started. So on the left-hand side, if we have a composite type, it's a pointer, then we're going to wrap that in a dereference, right? So this is how the compiler automatically converts pointers into something that you can navigate through if it's a composite, if it's a pointer to a composite type. And then for the right-hand side, so if we're in a member access binary operator, we infer the type of the right-hand side. If it's a pointer and the base type of that pointer is a composite type, then we wrap that as well. So this is if you have player.pos, so pointer to player dot pointer to pos dot x, right? It's going to be dereference pointer to player, dereference pos, then x, whatever. Let's say x is a float. So then you're going to actually get the float value at that point. And then in proc call, again, this is kind of similar to in the argument list. This should never be null. If it is, we bail. And that was a case I wasn't handling properly. In element builder, I just check for nulls here. We should never get nulls, but I just go ahead and add check for them. In session, I added a helper should read variable, pass in an element pointer, and then it decides, based on some rules for how we navigate things, should we actually invoke a read on that variable, which would cause it to be evaluated, or can we skip over it? And then I refactored this quite a bit to make it, I think, a little bit simpler, and to take the parts that always happen out of the loop, just they happen, and then we have the loop after that. So I got rid of the temp variable, the temp var, and then we just have the array of vars now. And then the left-hand side, we always do that, right? We were always falling into that. So I just hoisted that out. We do that once up front, then we move into the loop. And so then this is the same, it's just restructured slightly so that it's just dealing with the right-hand side listing of member accesses until that's exhausted. I moved where the disassemble happens. It was in the finalize, but if the interpreter bombs, I can't always see what code it generated, so I move that. We generate the code, then we run. So, and then also that leaves the output from the program at the bottom, so I don't have to keep scrolling up. I did that long enough. So, and then should read variable. Obviously, if we pass null in, it's false. If it's an identifier reference, it's false. Otherwise, if it's any other kind of element, we're going to assume we need to read it. This probably will adjust a little over time. There might be some other cases where we don't really want to read things. For the unary operator pointer dereference, this needed a little bit of massaging to be correct, right? So for composite types, it doesn't make any sense to load the value of that because it's not primitive. So in this case, we say, okay, if it's a composite type, really all we want to do is just make sure that the addressing address variable for the unary operator is moved into the target register that was passed in through emit. Otherwise, if it is a primitive type, then we're going to load the actual value of that primitive type through the dereferencing. And then in variable, for field, now there's a case. So we have two overloads for field, one that takes an element and a handle and an activate, one that takes a name. In this case, this guy essentially just proxies to this, but we want to pass the element through in some cases because we want that to be the thing the variable gets created for. So I added a header. In field, I added that element. Typically it's null, but in some cases it's not, right? So if it's non-null, that's the element we pass into the variable call. If it is null, we just use the identifier like we were before. And then in the version that takes the element, we're doing a little bit more work now. If the element that comes in is a unary operator, we dig in there, grab the identifier out, and then use that to look it up. But we also pass that element through. So we're guaranteed to get a variable that's containing the correct element. Because if it's a unary operator, like if it's a pointer dereference or whatever it is, if it's some complex expression, we want that to be the thing that gets evaluated. And that fixed all that. Am I basing Basecode syntax on any other language? Sure. I mean, there's bits and pieces of Pascal in here. There's some C in here. The story of Basecode, though, is that the syntax really that we're looking at here is what I call Basecode alpha. It's and I might actually change that to some other term, but this is the way to look at what I'm working on right now. This is like the assembly language of Basecode. It's very simple. It's not a super fancy language. It's not intended to be. It's low level, and it lets you solve problems, or it lets you implement things, and it tries not to get into too much in your way, right? So there, you know, it's statically typed, it's type safe. I'm trying to address a lot of the issues that I see with other compilers in terms of where they tend to like waste time and where you run into problems. But again, like at that level, Basecode Alpha is not, there's nothing really super special about it. Where the specialness comes from is the meta programming system. And of course the meta programming system is, you know, you can do that all in the same language. You can do that all in Basecode Alpha. And this is the Bootstrap compiler, so it's really just meant to get me far enough into having a running compiler that will manage Basecode Alpha, so that I can then re-implement Basecode, the Basecode Alpha compiler in Basecode itself, because I want to get away from C and C++ for that. And then once the compiler is self-hosted, then I'll be doing another round of enhancements on top of Basecode Alpha, which I'm calling Basecode Beta. Again, these names are temporary, right? And Beta is going to have a series of new features that are designed around specifying language constructs. So you'll be able to code up something essentially in a eBNF type format, and then the Basecode Beta compiler will take that, it will generate, you know, Lexer, scanner, tokenizer, whatever you want, a combo of that, and then it will build a parser and an AST generator for you, and then the Basecode Beta language will have a new set of constructs that allow you to say, here's an input stream of, you know, tokens. Here, use this language, use this grammar, and then it will give you an AST, and then you can map that AST to actual code, Basecode Alpha code. And because it's all meta, right, whatever code you say, if you say this AST element of this language maps to this block of Basecode Alpha code, then that's what gets compiled for that. So then in a source language, let's say you had VB, or you had Python, or you had Ruby, or whatever you had, those things can then be translated on the fly. And then from there, you know, who knows where it goes. Now, all that I just said, I mean, that's probably realistically, like, I do not expect that I would have the Basecode Beta pieces done until sometime, probably this time next year, would be my guess. So it's going to be quite some time before it's fully complete. You know, channels is not again, my approach is different, right? I'm not building a kitchen sink language. I'm not trying to build a language that has a fixed syntax that says, here are these things, this is all you can do. Good luck, right? I think that's a fundamental problem with what we have today. If you want channels, you can build that yourself, right? If you want a garbage collector, you can build that yourself. If you want class-based OO, you can build that yourself. None of that stuff's going to be baked in, because I think that's a big mistake. with a lot of the languages we have today. The paradigms are too fixed, and I think in the future that's not a very pragmatic way of approaching this stuff. But again, we'll see. So, is this the last stream? This is not the last stream I'll ever do, but it is the last stream for the near term. I don't really know what my schedule is going to look like. It's probably going to be all over the map for the next several weeks at a minimum. That's not to say I won't maybe stream here and there, although it probably won't be on my typical schedule. It'll be wherever I can get a few hours here or there to be able to stream. So what I would say is after today, going forward, the stream will be ad hoc. It will be essentially whenever I have the ability to block out some time and stream. And I'll try to advertise that like on Twitter or on Discord as far in advance as I can. Unfortunately, like Twitch got rid of their little channel feed thing, which I don't know. Honestly, I thought that was a little bit useful because at least it was on the channel page, and if you were a follower or a subscriber, it would ping you, right, if I put something on there. So, I think they assumed everybody just uses Twitter, which is true, but obviously everybody who follows me on Twitch isn't following me on Twitter, so, and not everybody is on the Discord server, but I will try to use those to, let you guys know if I'm planning to stream. And yeah, and so we'll see how my schedule shapes up. It could very well be that within a month or so, things kind of get into a controllable rhythm, and maybe I can get back to a more regularized schedule. So we'll see how that turns out. But am I going to retire after Basecode? No. I have so much I want to build, and really, like I kind of see Basecode as getting Basecode to the point where I can use it to start building those things. That's really the way I want to approach stuff. So, yeah. I wouldn't say I'm going to retire after Basecode. I would say Basecode's probably going to be like the beginning of a whole bunch of new stuff I want to build. And I'm hoping, I don't know for a fact, but I'm hoping that Basecode will make it much easier for me to do that. So that's the plan. We'll see how that shapes up. So I will continue to work on, I will be working on Basecode and other projects I've got going on. If I could, would you do streaming full time? I don't know, man. Here's the thing, right? So it's October. I started streaming at the beginning of January this year. So I haven't quite made it a full year yet. And in general, I think streaming is fun, and it certainly gives me an excuse to talk to myself, versus me just talking to myself and my wife thinking I'm insane, or my kids asking who I'm talking to. But I will say this, when I first started, it took me about a month or two, to really kind of get to the point where I was able to do, I felt like it wasn't impeding my coding too much, right? And after that, I would say for the most part, other than, occasionally reading chat and just kind of occasionally keeping an eye on OBS and just making sure stuff is working, it's not too much of a overhead or whatever. The thing though about streaming, right? And I think I've been pretty lucky actually. And I don't know if it's just the topics I've covered, the stuff I'm doing, if it's because everybody just likes to listen to me talk, I don't, or a combination of all those. But I mean, I think I've gotten a pretty decent following, larger than I expected I would. But at the same time, I do think that the part that you don't necessarily think about with streaming until you're doing it a lot is that it's entertainment. Right? At the end of the day, yeah, I'm sure some of you guys are learning stuff and you like to follow, but it's occupying time. It's filling a slot. Slayer Darth is at work and he's listening to me in the background, and occasionally he looks at chat, occasionally he maybe looks at what I'm doing, but it's like listening to the radio or having the TV on in the background, and that's totally fine. I mean, that's what this is, but that brings with it an extra dimension, right? At some level, it's very difficult to just say, well, I don't care if anybody likes what I'm doing, right? I'm just going to do it. And obviously, you could take that approach, but you're probably going to lose your audience, right? You're going to lose people if you're just completely out there doing stuff that nobody cares about, or you're not communicative or don't interact very well. So it's its own thing. And again, while I enjoy doing it, would I do it full time? I don't know. Probably not. So, because then the question, becomes, are you doing things because you think the stream wants you to do them? And this isn't even just true of Twitch, right? This would be true of making YouTube videos or anything. Like, where's the cart? Where's the horse? Who's driving what? Is the tail wagging the dog, or is the dog wagging the tail? I wouldn't say it's onerous or anything. It's like anything like this. If you treat it somewhat seriously, you have to think about, okay, what is my schedule? Can I do that every day? What am I going to stream? What is the content that I'm going to provide? Does that align with the things that I want to do, right? See, if you're a gamer on Twitch, and again, I don't want to trivialize it. Some of these guys work a lot, but I take that thought back, because I've read and I've heard people say they hate playing the games they play, but they keep playing them because that's what their audience expects. So I think it's true of anything, on stream. So I guess that whole little ramble was just me saying there is an overhead to doing it. There is a dimension to it if you're taking it seriously, right? I mean, obviously, again, you could just turn on a camera, have a mic, and show up, and if let's say you're writing everything in mumps, people might like drive by and say, wow, that's the weirdest language I've ever seen in my life. And if you're okay just doing that, sure, granted. And again, this is not me complaining, or this is just me kind of trying to answer that question of whether or not I would do it full time, and the thoughts that go through my mind, right? Of, is what I'm doing boring? That sort of stuff, right? And it's, again, it's hard not to go through those mental hoops and think about that stuff on some level. So, but yeah, I think somewhere between, I was doing the 5 hours. I actually like doing those 5 hour sessions. I would think that would be kind of the max for me. And yeah, I probably wouldn't go too much beyond that in a given day. Somewhere between 2 hours and 5 hours is probably, at least for me personally, and I think for programming in general, is probably about the right amount of time. Yeah, Lori Master has a good point. You know, Twitch, here's the thing about Twitch that I guess I like. It was relatively easy to get set up. Stuff more or less just works. You know, I had a bunch of issues with YouTube streaming. Wasn't really super pleased with the way it worked. And, but yeah, this is obviously guys like me who are streaming programming or folks that are doing stuff that's not gameplay or whatever, what Twitch was originally designed for. It's obvious that the vast majority of the folks that are consuming on the platform are not consuming content like what I create, which again is fine. I mean, I kind of shit my shorts if we get 100 people on, the channel. That's a lot of people. And I mean, I watch streams by, Casey and John, and they get hundreds of people, and it's just, chat's just constantly going. And at some point, then it's really difficult to interact, right? You're trying to constantly catch stuff as it's running by. So on the one hand, it would be cool to have really big audiences. On the other hand, I think there is, for this kind of content, I think there is kind of a breaking point where it isn't as beneficial as you would assume. Would you still work for other companies if your online presence would generate enough income? If I made sufficient money from producing content like this, sure, I wouldn't work anywhere else. I mean, I would just do this. The problem is, and I'm sure all you guys know this, the internet is, this stuff is just free, right? I mean, really, when you get down to it, I mean, you can try to monetize it, you can try to build things around it, but like that's a whole thing all on its own. And unfortunately, at least for me and the research I've done around how to monetize this stuff, I mean, look at what happened. Philip DeFranco had a thing just here the other day with his help and support thing, and people are attacking him on that. You end up pimping stuff, right? You end up either advertising for people, or, taking advertisement from people, or you end up, trying to sell, my book on knowledge and how to be a successful blah 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 blah. And some people can do that and get behind it, and doesn't, like, their scruples don't get in the way of them doing that. I really have a hard time with that stuff. And unless you're a Boogie 2988 or you're some other kind of in real life crazy making a fool of yourself streamer, it seems like you're not going to get a lot of subs. It seems like you're not going to get a lot of donations. And, I'm going to get in so much trouble for saying this probably, but if you're a guy, right, you're not going to get money on this platform, right? I mean, I don't have to go into a great detail as to why the fairer sex is going to attract, especially if they're attractive, and they play that up. And that is not a negative commentary on them. I'm jealous, right? But yeah, we guys don't have the assets to accomplish that goal. And from what I see, right, there is definitely things lean in that direction. So, or I should say, this is one example of where women have an edge and guys don't, right? So, and I think especially in tech, right, guys are, if there's a smart woman who's talking tech, those are both assets, right, that then attract a larger audience and attract, money, right? So, so yeah, I mean, in theory, if it could be done, then sure, I would do it. But reality, I'm not really quite sure how you would monetize. And like YouTube has made all this stuff way more complicated now. I mean, I get a lot of views. I have plenty of viewing hours on YouTube, but I can't get 1,000 subscribers. I mean, it'll take probably another year before I have 1,000 subscribers on YouTube. And then at that point, because of all the monetization things and all, is there even really any revenue there? Yeah, Patreon's an option. I've considered it. So, I mean, it's certainly a possibility. It's it's one of those things where I guess the long and short of it, the monetization for this sort of thing is, if you're going to do it, then it has to be like, I have to start pushing that angle, right? I have to start saying, okay, everybody, I really appreciate you dropping by. If you want to keep getting content, go to Patreon and give me, and that's okay. I mean, I could do that. But I haven't turned on the Carnival Barker routine in my brain yet. So, yeah. I know there are people who make tons of money with Patreon. So, but again, it's a Jordan Peterson who's making millions of dollars ridiculing SJWs on Patreon, and somebody like me, how much exposure can I get to code for people with code between Twitch and YouTube and other places to be able to make enough money? I think part of the issue is that low-level code isn't an inherently appealing to younger generation of coders or coder wannabes. Okay, so this is my exact point, right? Like I have a brother, and he's in sales, okay? And he tells me every time, you need to make videos about how to turn your computer on. He's like, you need to make videos about, how to plug things in. He's like, that shit would attract tons of people and people would pay for it. And I'm like, yeah, you're probably right, but that's not what I want to do, right? That's not what I am. Likewise, I could compromise, right? I could say Python and AI and React and Vue.js and all that shit is super popular. And just from a pure, this is popular, therefore it will sell perspective, I could focus on that. But this is what I was trying to, talk about earlier. That's a different thing than what I set out to do, right? I am making a conscious decision to spend my time doing things that I don't necessarily want to do. I don't want to write a blog about React. I don't want to write code for the web, right? I don't, right? Certainly I don't want to do it with the stuff that's out there now. So I could do that, but then I'm making a conscious choice to do it for marketing reasons. And then it becomes a blog, or then it becomes a business, right? Then it becomes, I'm doing this because this is what sells. And then I'm an actor in the thing talking about stuff that I really don't have any energy behind. And that's, and so you're absolutely right. That's what you could do. You could go find the really popular shit, but then that's the other thing. That changes. It changes constantly, right? Right now, it's Python and OpenCV and, whatever, AI nonsense. In 12 months, Python will be a pile of shit. Nobody will want to talk about Python. How could anybody have ever written code in Python? That was stupid. Now it's Elm or whatever. And then that's the hot shit. And then whatever, something else will be the hot shit. And so then you're just constantly chasing these trends. And yeah, that's just something that doesn't really appeal to me. So yeah. Anyway, I got to run, guys. I got to take my daughter to school. But I will be back. I'm not going away. I will keep everybody updated, and I will probably slip some stuff in over the next couple weeks where I can. They probably won't be excessively long streams, but I probably will get some in here and there. And yeah, so thanks everybody for dropping by, and I'll see you guys when I next see you, and have a good one.